this relationship between the student and curriculum, or between student and course. Like that, we can give other examples, like say employee works in department. Then what is meant by cardinality is the minimum and maximum number of occurrences of one entity that may be related to a single occurrence of the other entity. So let's look at it again. Defines the minimum and maximum number of occurrences of one entity that may be related to a single occurrence of the other entity. Now we can show this by this, in the line you cross it like this, that shows exactly 1, or it can be shown by this kind of double lines crossing the line. So that shows exactly 1, that is not 1 or more, but only 1 and only 1 occurrence. Cardinality, if you use this symbol, then it shows it is 0 or 1. Then if you show this symbol, it will be 0, 1 or more. This could mean 0, 1 or more. So here if you give an example for this, I might be married or not, either married or not, 0 or 1. Then in this case, I may have some friends or none. I may not have any friends, or I may have one friend, or I may have many friends. This is used to, this symbol is used 1 or more. As an example, we can say I have to work at least in 1 or more projects. Then more than 1, I am working in many projects. So see the difference between these two. Here it has a line that crosses this main line, the relationship line, and here it does not have a line crossing. So what he is saying is, implies is I am working on many projects. Then the degree describes the number of entities that participate in the relationship. So the degree can be 1, or here we are showing recursive relationship that exists between different instances of the same entity. So here in this case the degree is 1, because you can see this entity type called the employee. Now it is an employee who will supervise other employees. So this kind of, it is not between two different entity types, it is between the same, it's a same entity occurrence is supervising the others. So here what it means is, one employee will supervise many employees. So that kind of relationship is called a recursive relationship, and the number of entities that participate in this relationship is 1, because it is only the employee entity that is participating in this relationship, and therefore we call the degree 1. Now if you take this example, here we have an entity type called employee, and there is another entity type called the department, and this is a binary relationship because there are two, when two different entities participates in a relationship, you call it a binary relationship, and the degree of the relationship is 2 because there are two entities. Now if you look at this, there is a ternary or triary relationship. There is a project, employee, assignment. So this has a relationship, assignment has, on one side it has a relationship with the project, and on another side it has a relationship with the employee, and on the other side it has a relationship with the location. So there are actually 4 types of entities here, and the entity type called assignment has relationships with project, employee, location. So here the degree is 3, and when more than 2 different entities participate in a relationship. So there are 3 here, therefore the degree is 3. Now synchronization of system models. Now, we have looked at process models and we have looked at data models. That is, we have looked at the process models using data flow diagrams and data models using the ERD diagrams. So, these represent really different views of the same system. We are not looking at different systems, but we are looking at different views of the same system. And these views are interrelated, because as you saw, data and inputs, outputs and processes, these are all interrelated. Thus, modelers need to synchronize the different views to ensure consistency and the completeness of the total system specification. So, synchronization is the process of maintaining consistency between the different types of models. For instance, let me go back to it a little bit, because say supposing in the data flow diagram you show some data stores, and if those data stores are not considered in your entity relationship diagrams, then there is something wrong. So, what you have shown in your data flow diagrams must be consistent with what is shown in the entity relationship diagrams. Then we get on to another technique called object modeling. This is a technique for identifying objects within the system environment and identifying the relationships between those objects. So, without looking at processes and data separately, here we are looking at objects. And object modeling techniques prescribe the use of methodologies and diagramming notations that are completely different from the ones used for data modeling and process modeling. So, the notations that we use to depict data flow diagrams and entity relationships diagrams cannot be used for object modeling. In the late 80s and in the early 90s, there was a method introduced by Grady Booch called the Booch method. Then we had James Rambo introducing object modeling techniques, then object oriented software engineering methods. So, to avoid problems of having many different methods, in 1997 what they did was they sort of merged all these methodologies and arrived at the unified modeling language, or what you call UML. Now, here according to this, objects are defined as something that is or is capable of being seen, touched or otherwise sensed, and about which users store data and associate behavior. So, objects are defined as something that is or is capable of either being seen, we should be able to see them, or we should be able to touch them, or otherwise we should be able to sense, and about which users store data and associate behavior. So, again types of objects can be either a person, place, thing, event, or it can be something that can be sensed like a phone call or meeting. Again, we talk about attributes, the data that represents characteristics of interest about an object. For example, if we take a customer, our object is the customer. Now, what are its attributes? Customer number, first name, last name, home address, work address, contact number, etc. Now, there may be certain other attributes about this customer, but we do not really call them attributes, or we do not even store that data, because we may not be interested in such data. For instance, this customer's, what about his wealth, the amount of money he has in the bank, we may not be interested in those things. So, those are also attributes about this customer, but what we are not interested in about the customer we will not store, therefore, we will not call them attributes. So, there may be other details about your object, but essentially we are not interested in all those characteristics of of your object. We are only interested in what is of interest to our system. So, therefore, we store only those attributes. An object instance is each specific person, place, thing or event, as well as the values for the attributes of that object. For example, if we take the object called customer, there will be many customers like this, and for each such customer we have to store these attributes, sometimes referred to as an object. So, all this object instance, sometimes you may call it an object, but within that object what you have to realize is there will be number of instances. Say the customer object will have a number of instances of customers, usually drawn using a rectangle with the name of the object instance. The name consists of the attribute that uniquely identifies it, followed by a colon and then the name of the class in which the object has been categorized. So, let us look at it. One object instance, example, a customer object instance, object name is underlined and centered. This is the object name, and 001 customer number is 001. So, you see the colon and the underlining and all that. Customer number is 001, last name is Pereira, first name is Anne, home phone number is this, and the city is Colombo. So, this is the way you will really show an object instance. The name of the object is the customer and one instance of it is shown by these various attributes that describe that particular customer. 001 is that customer's number, name is Anne Pereira, and so on. Then the behavior, the set of things that an object can do and that correspond to functions that act on the object's data or attributes. So, this object may be able to do certain things and those functions should correspond to certain actions that you can take on the object's data or attributes. These are also known as methods, operation or service. Example, if you take the object door, the object name is door. The behavior or the methods or the operations or the service that you can perform on this object called door, you may open the door, you may shut the door, or you may lock or unlock the door. So, those are various things that you can do, things that you can, or methods, you call them methods or you call them functions or you call them operations or you can also call them services, and these do various things to the object's data or attributes. Then there is another concept in object modeling called encapsulation. Encapsulate means really a packaging of several items together to form one single unit. So, here what do we really in object modeling, what do we package together? The attributes and behavior of the object are packed together. The only way to access or change an object's attribute is through that object's specific behavior. So, the way you can change an object's attribute is only through that through specific behavior of the objects. Now, objects encapsulates what they do, that is they hide the inner workings of their operations from the outside world and from other objects. Now, if you look at an example here, when an object carries out its operations, those operations are really hidden from the outside world. When most people watch a television show, they usually don't know or care about the complex electronics that sit in the back of the TV screen or the operations that are happening. So, the TV really hides its operations from the person watching it. When we are watching a TV program, we are only interested in what is shown on the screen. We are really not interested in how this is shown and what are the electronics behind that TV screen and so on. We are not interested in, and nor are those being shown to us. So, similarly in these objects also it is the same thing. Operations are actually hidden inside the object. Then we look at another concept called object class. A set of object instances that share the same attributes and behaviors is called an object class. Now, if you look at this example given here, we have an object called book. Each book has an ISBN number to identify the book, the title, copyright date, edition and so on. So, these are the various attributes of this book. And what are the methods or the operations that you can do is open the book, close the book and so on. So, those are the behaviors or the methods or the functions that you can do, and these are the various attributes. So, if you take a number of instances or number of books, then they all belong to this class called the book. We can give a generic name called book to this class, and each one will have, each instance of book will have a specific ISBN number, specific title, copyright date, edition and so on. So, a set of object instances is what you call an object class that share the same attributes and behaviors. They can be described by these various attributes. Of course, they will have different values for each one of these attributes for different instances of the class book. And the methods that you can, or the behaviors are like open, close and so on. UML notation for the object class book. In UML, you show the object class like this with this kind of notation. Now, if we look at another instance, an object instance of the class book, here we write the ISBN number, because that is the key by which you identify, because you can see ISBN number varies from one instance to another. Now, this says 007 231 5393, whereas in this particular book it is a different code. So, ISBN varies from book to book. So, therefore, this is the key to identify one single instance of a book. Here the title is systems analysis, this is programming in C++. Now, there may be many books in programming in C++ having the same title, but the ISBN number will be different for each one of those. Copyrighted date. Now, can we identify one instance from the copyright date? We will not be able to identify, because there may be many books which has the copyright date as 2001. So, even the edition is not sufficient to identify, because many books will be in the form of their second edition, third edition, fourth edition, fifth edition and so on. But when you take this ISBN number, that will be the unique key by which you can identify each instance. Then there is another concept in object modeling, what is called inheritance. This is the concept wherein methods and or attributes defined in an object class can be inherited or reused by another object class. So, we will look at some examples for these things. Examples: some individuals in the room might be classified as students and teachers. Thus, student and teacher object classes are members of the object class person. So, in the same room you have these two different types of people. That is, you have certain type of people called student and another type of people called teachers, but these all, they are all persons. So, what is common to person will be inherited by the student as well as the teacher. There may be certain attributes and methods in person which can be passed down to the student and the teacher as well. That means, can be inherited by the student or the teacher. So, this is this has been shown in a diagram. You have a class called person. Now, in this person class, there is one type of class called the student. There is another type of class called the teacher. In the same room you have these persons, but one person can be a student, another person can be a teacher. And again, within the student class there may be number of instances of students. There can be a student A, student B, C, D and so on. Similarly, teacher also can be, there can be many teachers, teacher A, teacher B and so on. So, there are many instances of person, there are many instances of student, there are many instances of teacher. Then another concept in object modeling is what is called generalization or specialization. This is a technique wherein the attributes and behaviors. So, we have seen our main object with attributes and the behavior or the what you can do with those. So, object wherein the attributes and behaviors that are common to several types of object classes are grouped or abstracted into their own class called a supertype. The attributes and methods of the supertype object class are then inherited by those objects called classes or the subtype, sometimes abbreviated as gen, that is generalization is abbreviated to gen and specialization is abbreviated to spec. So, we will look at this from an example. Now, here we have the object type called person, and then here you have another class called student. There is another class called teacher. Now, each person has a first name, last name, birth date, gender, female or male. So, these are various attributes. And what methods or functions can they do? A person can walk, a person can jump, a person can talk, a person can sleep. So, these are various functions or things that they can do, or methods or their behavior. Now, when we take the type of person student, now student will inherit the first name, last name, birth date and gender from the person, because we say student is a type of person. Similarly, teacher we say is a type of person. Therefore, teacher also will inherit all these attributes and all these behaviors. So, if we look at this finally, student, in addition to this first name, last name, birth date and gender, will have two other attributes that is not common to person, therefore, will not be inherited by the teacher. Those two attributes are GPA and classification. So, while these common things can be inherited by both, what is special for the student cannot be inherited by the teacher. Similarly, the teacher has an attribute called rank. Now, the rank cannot be inherited by the student, nor can the rank be inherited to the person. What is available to the person can be inherited both by the student and the teacher. So, in addition to these attributes called GPA and classification, the student will inherit the first name, last name, birth date and gender as attributes, and the methods or the behaviors, student can enroll, student can display GPA. In addition to that, student can walk, student can jump, student can talk, student can sleep. So, these are the behavior that can be inherited by the student from the supertype of object called the person. So, we have the supertypes, we have the subtypes, and similarly the teacher will inherit these attributes, plus they will have another attribute to describe themselves as rank. And in addition to walking, jumping, talking and sleeping, the teacher can also lecture, which now this lecture cannot be inherited by the person, because this is only a subtype under the supertype, and lecture, this method or behavior cannot be inherited by the student, because this is unique only to this subtype. Enrolling and display GPA can be only done by the student, not by the teacher. So, basic idea of generalization, specialization within the same class, you can have specialties and what can be inherited by the subtypes from the supertypes. Similarly, we can see another example. So, this is the one that we discussed just now, person, and you can see this symbol, student, teacher are subtypes of the supertype called person, and here we have a supertype called vehicle, and the vehicle can be specialized to further extent. Vehicle can be a bus, it can be a car, or it can be a truck, specialized types. So, in common they will all have a vehicle number, then attribute called number, and certain methods will be common to all, but say number of passengers in a car, whereas in a truck how much of load it can take. So, these things can be, or the speed. So, those things can be special features or special attributes. Then object class relationships, like we saw the entity relationships, even among objects there can be relationships. A natural business association that exists between one or more objects and classes. The example, you interact with the textbook by reading it, with the telephone by using it. People interact with each other by communicating with them. So, there will be always interactions with this among these objects. When you turn on your TV, in object oriented terms, you are in an association with your TV. So, you are interacting with your TV, and association is unidirectional, one way, or it could be bidirectional, two way. Example is married to, like one way is unidirectional, two way, if it is a two directional association, you call it a bidirectional. Sometimes an object might be associated with another in more than one way. For example, Gehan, a person called Gehan is a co-worker of Damit. So, there is one kind of relationship here between Gehan and Damit because they are co-workers. Again, there is another kind of relationship between Gehan and Damit. Gehan is a friend of Damit. So, there can be more than one way in which these objects are associated with each other. If you look at this association some more, a customer places 0 or more orders. We say there is object called customer and there is object called order. A customer can place one or more orders, or he may not place any orders at all. There may be customers who has not placed any order at any given time. So, here it places represents a relationship between the classes. You say places, customer places the order, and this symbol symbolizes 1, 0 or more orders. At any given time, he may have placed no orders or he may have placed more orders. On the other hand, you can say an order is placed by one and only one customer. When you read the relationship this way, it means order, if you take one single order, it can be placed by only one and one customer, because one order cannot come from several customers. For a particular order, it should arise from only one customer. So, multiplicity is another concept in object modeling. Multiplicity describes the minimum and maximum number of occurrences of one object class for a single occurrence of the related object class. If it is examples exactly 1, then 1 or leave it blank. You denote it with a 1 or just leave it blank. 0 or 1, 0 to 1. 0 or more, either you can use this symbol 0, 2 dots and the asterisk, or just the asterisk. 1 or more is denoted by 1, the 2 dots and the asterisk. If there is a specific range to be described, then you say 7 to 9 or whatever the numbers. If you refer to the figure 10.5 in page 377, in the reference 1, you will have more details and examples given for this kind of associations. Then another object that another concept in object modeling is what is called aggregation. Why we are actually, you might wonder why we are describing only these concepts and without showing actual object modeling, because in another course you will be learning object modeling and designing in greater detail. So, that is why we are introducing only the concepts at this point of time, because you will do this later in more detail. Now, what we mean by aggregation is a relationship in which one larger whole class contains one or more smaller parts classes. Conversely, a small part class is part of a whole larger class. Now, if we give examples for this concept, a club, when you look at a club is made up of several club members. So, you have your whole class called the club, and it is made up of part classes called members. If you take a computer contains a case, a CPU, motherboard, power supply, etc. So, it contains many parts. So, aggregation can be shown like this. Say you take a glider plane, the UML notation used here, it could have 0 or more engines. And if you take the team can have, this is a range given 12 to 18 players. This is the whole object is the team, and the part objects are the players. So, this is 0 or more, this is also 0 or more. Engine can be in either, maybe it is not in any plane, or it can be in one or more planes. So, player can be in a 0 team, or he could be in more than one team. Then there is another concept called composition. This is an aggregation relationship in which the whole is responsible for the creation and destruction of its parts. So, if you, in this case, if you destroy the whole, that means all its parts will be destroyed. If the whole were to die, the part would die with it. A stronger form of aggregation is the relationship between club and club member would not be composition, because members have a life outside the club. That is, even if the club was disbanded, still the member will live, because the member has a life outside the club, and also they can belong to multiple clubs, not only a single club. So, even if one club closes down, still the member will survive, because they can exist as members of other clubs, or they have a life outside that club. Now, composition has been shown here, school and the department. Each part can belong to only one whole. Therefore, multiplicity needs to be specified, only one for the part. Components will live and die with the whole object. So, if the school dies, then all the departments also will die with it. Then another concept in object modeling is what is called polymorphism. Literally meaning many forms. Polymorphism basically means many forms of it. The concept that different objects can respond to the same message in different ways. Consider the example, the window and objects. Now, the window behavior close. Door also can have the behavior close. So, these are two different objects. Window is one object and door is another different object. Now, both can have the same behavior. Window can be closed, but the way it is done, window can be we can slide the window downwards and close it, whereas a door we have to swing it shut. So, the way you do it is different. Both have the common behavior, but the way it has been carried out differs from one to the other. In this case, you slide the window downwards and close it. In this case, in the case of the door, you swing it shut. So, polymorphism really means many forms, that is, an action can exist in, the same action can be done in different ways.